Hello, so today I'm going to explain the octet rule. And if you've taken a chemistry course before, I'm sure you've heard of this. If not, don't sweat it, I got you. It is such a simple concept once you really start understanding each of the elements and how many valence electrons they contain. And in doing so, you're going to have a periodic table. That is the only way I figured this out. It states by the groups how many valence electrons each element has. And in knowing so, you're going to be able to tell whether an atom needs to gain an electron to satisfy its octet rule or lose an electron to satisfy its octet rule. So let's start off by defining octet. Octet, I'm sure as you know, has something to do with the number 8 because its prefix is oct. And I'm sure you've heard of an octagon before or an octopus, which an octagon contains 8 sides and an octopus contains 8 legs. So as you can tell, octet is going to contain 8 electrons, and they're all going to be on the outermost shell, and they are going to be defined as valence electrons. But before we jump into valence electrons and all that fun stuff, I want to give you guys the definition of the octet rule. So as you see here on this screen, the octet rule is defined as a stable group of 8 electrons occupying a single shell in an atom. Specifically, the outermost shell, with a few exceptions, of course. And when an electron falls in the outermost shell, it is labeled as a valence electron. It's essentially the same thing as an electron. And how we determine the valence electrons in an atom is from our periodic table. If you know the protons, you will know the electrons, and therefore it'll give you the valence electrons. You just have to write it out. What's nice about a periodic table is that it lists them in groups, telling you how many valence electrons they have, which it's not that hard to figure out, but it's kind of nice and convenient that it already tells you how many valence electrons each atom contains. So I'm going to go ahead and put a periodic table on the screen so you and I could break it down together. Alrighty, you guys, so here is a photo of a periodic table, which I'm sure all of you guys have seen before. I'm going to pick one element and explain it to you guys so you have a better understanding of how a periodic table works. Okay, so let's take carbon for instance. We start off with the atomic number being 6. After the atomic number comes a symbol, which in this case is a C. And after we have the name, which is carbon. Last but not least, we have the atomic mass, which is approximately at about 12. So the number we want to focus on is the atomic number, which in the case of carbon is 6, meaning it has 6 positively charged protons and 6 negatively charged electrons, which is indicative of this atom being in a neutral state. Okay, so back to the periodic table. These elements are categorized in groups 1 through 8. 8 being noble gases, which means they have 8 valence electrons, and all elements want to achieve the noble gas configuration. Okay, so here I have 2 chemicals. Lithium is on the left side and fluorine is on the right side. As you can see, on the outermost shell of lithium, it has 1 valence electron, and fluorine has 7 valence electrons, which means lithium falls in group 1 on your periodic table and fluorine falls in group 7 on your periodic table. Since lithium only has 1 valence electron, it is going to donate to fluorine because that'll require less energy than if fluorine were to donate all 7 of its valence electrons to lithium. When this happens, both atoms now have their outermost shell filled. But I know what you're thinking. Although lithium has its outermost shell filled, it doesn't satisfy the octet rule, right? Because it doesn't have 8. But I did say in the beginning of this video that there were some exceptions to the octet rule, and lithium being one of them. I'd also like to point out is that the reason lithium bonds with fluorine through ionic bonding is due to lithium being a metal and fluorine being a non-metal.
Alrighty, you guys, I just want to say thank you so much for listening, and I hope I was able to thoroughly explain what the octet rule is. and everything it entails. But I do want you guys to keep one thing in mind. There are many exceptions to this, and the octet rule is not the end all, meaning it is not the only reason why atoms bond. They can bond through electrostatic attraction, and there's energy changes when bonds form. So there's a ton of things to keep in mind, but as long as you know the reason atoms bond is to minimize energy and to be in a more stable state, you will be just fine. Take care.